Hi, this evening's lesson is going to be on multiplication facts, and it's supposed to be a way to simplify learning all of those multiplication facts. I am a tutor for the Seeds of Literacy program, and that's who this is for. The multiplication facts when you were in elementary school, they usually are just talking about the facts multiplying by 1 all the way up to multiplying by 10. And then when you get middle school, maybe even a little before that, all of a sudden people just expect you to know all of your 11s and all of your 12s. But I know in many schools, in many situations, that was never even taught. You were just supposed to pick that up.
Yeah.
And there are a lot of them. Let me see if I can get it to transition. There we go. There are a lot of facts. There's actually, when we go all the way up to 12, there's 144 multiplication problems, and it can be really overwhelming. The multiplication table is a form that I really like, and I think it's a great way for people learning their facts for the first time or going back and refreshing. I think it's a great way for them to practice. The multiplication table is set up so that whether you're reading across, like this red row, that's all of the ones tables. The dark green, these are all of the sixes going across. But then also, you can read down. So the dark green going down, that's also all of the sixes. So they're very well organized, and you can find tons of patterns in here. And if you are struggling with remembering your facts, practicing on a table, a blank table that you're filling in, where you can use strategies like patterning can be really helpful. So a lot of multiplication tables you'll see are set up something like this, and then they've got a line down the middle. This one made it red. And that line, if you haven't already figured it out, kind of divides the multiplication table. All of the problems on the lower left and all of the problems on the upper right, they're actually duplicate problems because of the commutative property. Like, let's say 3 times by 6. So 6, if you can see my red pointer, times by 3 is 18. And they've got it right here on the multiplication chart. But we could also go across our 3s over to 6, and that same problem appears again, and it's 18. So the multiplication chart in itself is deceptively big. So almost half of the chart is duplicate information. So I wanted to explain what that meant in case anyone was not quite understanding. So here is part of our multiplication chart. And this number right here that was missing, this 6, it's 3 times by 2. It's the same problem as 2 times by 3. So this number was 12. That's the product of 4 times by 3. That also appears right here, 3 times by 4. 18 is the product of 6 and 3, and it also appears on the right side of the chart. And you can see all of the missing blanks on the left side they appear on the right side of the chart as well. So one of my goals today is to take the huge chart of 144 math facts and break it down to a manageable quantity. Okay, so the multiplication table again, multiplication chart, whatever you want to call it. I just wanted to say this lesson, I've been wanting to design this lesson for many, many years, because I've taught in elementary school, I've taught in secondary schools, and now I'm working with adults. And there are 3 types of math students. It doesn't matter what age we're talking about. There are those people that you give them a task like memorizing their math facts, and it's easy. They pick it up, it makes sense to them, and they get it quickly. And then, especially when we're talking about secondary or we're talking about adults, those people, maybe they knew their math facts a long time ago, but it's been a while since they've used them, so they need a little refresher. And so a little bit of practice can get you back to where you once were pretty quickly. But then there's a third group of students. And in my experience, for every classroom of 20 or 25 people, I would always have at least one, maybe two, that memorizing multiplication facts was one of the hardest things they ever had to do in school. And it has nothing to do with intelligence level, and it has nothing to do with how hard you work at it or how dedicated you are. There's actually a form of dyslexia that in some people, it makes it really difficult to memorize those facts. And it makes the recall of the facts really, really tough. And so I can't tell you how many years I would have students working on memorizing and getting good enough so that they could pass timed tests where they've actually got a stopwatch going and they have to quickly fill in the facts. And for some people, in my experience, 5% ish, they are just not able to learn them and recall them as quickly as others. And my feeling is, especially if this is something that's really, really hard for you, when we're looking at a multiplication table with 144 problems, 144 multiplication facts, it is overwhelming. And so it's overwhelming anyway for anybody, but when this is something super hard, it's can make you want to quit, can make you want to give up. So that's who I'm talking to today. So this is going to be our multiplication table. And this is how I'm going to kind of chart what we've talked about or what we've learned or what I can say we know. I'm going to keep pulling up this multiplication table and I'm going to fill in the problems that really we already know. Even if we felt like we're not great at having our facts memorized, a lot of it turns out we do know. For instance, the ones. Most of my students, there we go. All of our ones, most of my students know the ones. I mean, that's just not an issue. 1 times 1 is 1. That should be 2, 3, 4, 5, 6. So I'm going to go ahead and gray out all of the ones tables because I'm pretty sure that we all know those already. Okay, so the next set of multiplication problems I want to look at are the twos. And many people are pretty strong with their twos. It's not really a problem. If you happen to be a person who struggles a little bit with the twos, there are 2 strategies that I like. First one is called skip counting. So if you're good at counting by the even numbers, it would be like 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I'm a big believer in fingers, even for adults. If you have to do a problem like 2 times by 7, if you don't automatically have it memorized, I'm good with putting up 7 fingers. I might even put them down on the table in front of me and then count by 2. So try to do it so it makes sense. 2, 4, 6, 8, 10, 12, 14. And that's how it would work. Another strategy that a lot of my students like, I don't know, it's not my preferred strategy. It's the doubling strategy. You know, once you learn to add, like 2 plus 2 is 4, it's a different way to think of 2 times by 2. So if we've got 2 times by 4, well, that's the same as 4 and 4, which is 8. If we have 2 times by 8, well, that's the same as 8 and 8, which is 16. So if we've got 2 times 12, that's the same thing as 12 and 12, which is 24. So for some people that helps, and other people, they're just better off counting. So here's our multiplication table. We already knew our ones. I'm going to add the twos because I feel like most students I've ever worked with that these, they can get their twos. Might have to count a little bit, but they can get them. The next set of problems I want to look at are fives. And again, skip counting works great. Many people are able to count by fives, like 5, 10, 15, 20, 25, 30, whoops, and then all the way through. Again, if you have to do like 5 times by 8, and if you're not sure of the answer, I would recommend putting up 8 fingers. I have to make sure I can see them. Putting up 8 fingers. That way you remember, oh yeah, got to do it 8 times. And then start counting. 5, 10, 15, 20, 25, 30, 35, 40. And that's the answer. Okay. So filling it in. Let's add the 5s because most people, you know, if you have your fingers and you count by 5s, can get your 5s facts. 9. I love the 9s because there are so many interesting nuances about them. First of all, the answer to all of the 9s multiplication facts, that answer, the sum of the digits, it's always going to be divisible by 9. So if you're trying to remember 9 times by 4, if you remember it incorrectly, you can add up those 2 digits, and if it's not divisible by 9, then you know you have the wrong answer. Let me show you.
I don't know. I don't know. I don't mean to cut you off, but I don't know if you noticed something. I'm looking at the products of the multiplication facts for 9.
Right.
And I was looking at the digits on the left and right side of the numbers, and I noticed that starting from the bottom on one side, it goes up from 0 to 9.
Oh,
And
yes.
then starting from the top on the other side, it goes from 1 to 9. So that was
Taylor,
pretty cool.
I am such a math geek. I am so glad that you think that's cool. That's why I love that multiplication table, because there are so many patterns, and math is all about patterns. And that's exactly what you found. The tens places starting here, and actually technically there could have been a 0 right here.
Yeah.
So the tens places, it counts up to 9. And then in the ones place, it counts down from 9 to 0. That's awesome. Good for you. So
Thanks.
if you had trouble with your 9s and you were practicing on the hundreds chart, you could use that strategy to help you along. And the more you practice it, I like doing it on the hundreds chart too, because your brain is thinking about it, but your eyes are also looking at it, and your hand is also writing it. So your brain is kind of being encoded 3 different ways. So, but this little hint, the sum of the digits is always divisible by 9. So the problem, 9 times 1, the answer is 9. Well, yeah, add that up. That's just 9. But let's look at, which one did I do next? It's stopping on me. Okay. 9 times by 2, we've got the 1 and the 8 from 18. So 1 plus 8 equals 9, and that's divisible by 9. Let's jump down to 9 times by 6. The answer is 54. And so you look at the 5 plus the 4, and that equals 9. And actually, all the facts through 9 times 10, when you add up the 2 digits in the product, they're always going to equal 9. So if you're trying to think 9 times by 6, yeah, I know that one, it's 52. It's like you can just do a double take and be like, oh, wait, 5 and 2, that doesn't equal 9. I can't do that.
Now, is it like that with the other numbers? Like 5 and 7?
Wouldn't you want that to be true? That's
not.
Now, there are some others that are close, but not exactly. So with 11 and 12, you can see when I've got the answer to 11 times 9 is 99. Well, 9 plus 9 is 18. And 18 is easily divisible by 9. So yeah, that could be the right answer. Get it to transition. That was 18. In 12 times 9, the correct answer is 108. And so you have to think of that as the number 10 plus the number 8, and together that equals 18. So this is a strategy. Yeah, I think I did do more. Even way beyond learning your multiplication facts. So like when you're working with long division, fractions, ratios, proportions, or scaling, there are all kinds of times when you're looking at a number that is a large number and you have to decide, is this going to be divisible by 9? And you can do the long division to figure it out, but you can use this little trick to save you some time. For instance, I can get it to transition. There we go. So if I were to ask you, Tylisha, does 47,538, does that divide evenly by 9? See if you can use this strategy so that you know right away, will that be evenly divisible by 9?
Mm,
You know how to do it or how to
I
start
have
it?
no idea. No.
Okay. So we need to find the sum of the digits of this number. So when I say the sum of the digits, I mean that I want this thing to transition. There we go. I mean, we have to, oh, I didn't mean for all that to show. We have to add up the 4 plus 7 plus 5 plus 3 plus 8. So if we were to add up those numbers, it's going to equal 27. So do you happen to know off the top of your head, 27 divided by 9, does that divide evenly or not?
Yes,
It
because
does.
9 times 3 is 27.
You're awesome. It does. So because when we add up those digits, all the numbers that appeared in 47,538, we added them up and our total was divisible by 9, evenly divisible by 9, then that means the whole number, 47,538, is divisible by 9. So if you're doing long division or you're doing a fraction problem and you are looking at a big number and you have to know, oh, wait, should I, divide by 9 here, or, will 9 divide into this evenly? Add up the sum of the digits, and if that divides by 9 evenly, then the big number will. We've got one more to practice.
Okay.
Okay. Does 826 divide evenly by 9? See if you can do that one.
No, it doesn't. Because
You are awesome.
thanks.
Because we don't even have to know what the decimal answer is. But 8 plus 2 plus 6 is 16. We know that doesn't divide. There's going to be a decimal if we do it. So no, 826 is not divisible by 9. So that's a little trick that you can use way beyond just learning your multiplication facts. And and we'll come to some more that are similar. Unfortunately, that doesn't work for all of them. I wish. Now here's a trick that I really like. Tylisha, do you know the finger strategy for doing your 9s? I had a student teach this to me years and years ago. And it's funny because even at Seeds, I'll get some students and they'll have their hands on the table and they'll be using this strategy. Okay, so the problem is 8 times by 9 is the same problem as 9 times by 8. Just out of curiosity, Taylisha, do you know what the answer to 8 times by 9 is, or 9 times by 8? Okay, stop learning because I have an easier way for you to do that.
Is it
What did you
72?
say?
Is it 72?
I don't know. I'm not going to tell you. I'm going to make you figure it out this way. Okay. So the finger strategy looks like this. Oh, it keeps not wanting to transition. Okay. So the finger strategy looks like this. You put your fingers down on the table in front of you. And this trick only works with 9s. I wish it worked with everything. It does not. Only the 9s. So if we're multiplying 9 times by 8, when our fingers are down in front of us, we have to fold over our 8th finger. So can you see where they counted up here in blue? 1, 2, 3, 4, 5, 6, 7. Can you see those numbers?
Yeah.
Good. Okay. Now in green over here, it's kind of hard to see. Can you see that they numbered these fingers 1 and 2?
Yeah.
Okay, good. So we're multiplying by 8. So we fold down that finger. That's kind of our breaking point. We count how many fingers are on the left, and we have 7. And then to the right, we have 2 fingers. So our answer is, what's the answer to 8 times 9?
72.
You were so smart. You knew it to begin with, but you're one of those. I have a feeling that a few years ago, you probably knew your math facts down cold. Like I said, you've
Yeah.
got good math sense. It's just been a while, and so you need a little refresher. But
Yeah.
some people, it's much harder, and this trick absolutely saves them.
Yeah, that is a cool trick.
I love that one, but everyone
Yeah.
wants to use it for more than just nines. So
I
here's
know.
another one. 4 times 9, 9 times 4. It's the same problem. Use your fingers and try to figure out what 4 times 9 would be using that little finger trick.
Okay.
How's it coming down there, Taylisa?
It's not going well. I can't. I think I know the answer, but I I think that maybe I have to practice or look at the model again to actually learn the concept on how to
Okay, so
get that answer.
leave your fingers set up. Oh, except for you probably can't see the screen when you do that.
Um.
Turn it where you can see the screen. Okay, leave
Yeah.
your fingers on the table, set up the way you think they're supposed to be set up, and then I'll show you how they're supposed to look.
Okay. I think this is what I did.
Advance. Okay, so now look at that picture. So we're counting from the left, and we're multiplying by 4. So we fold down the 4th finger. There you go. Okay.
Okay.
Look at those fingernails, man. I can't wait till I have fingernails again. Okay. So on the left side, how many fingers do you have?
4.
No, you don't, because that one's folded.
No.
Oh, and I'm using
Oh.
my pointer to point to your fingers. You can't even see that. What am I saying?
On this side, wait, on the one that's down.
Yeah, so the one that's down, we don't count the one that's down. How many are still straight up on the other side?
On the other side, 5.
Okay, how about, okay, I
Oh,
have to
no,
do it
6.
because I'm messing up. Okay,
I don't get it.
so here we go. My fingers match yours, right? But it's funny because in the mirror, in the camera, it's backwards. Okay, so on the far left, and I'm looking at
I
your
can't
fingers.
put my finger down.
I know,
I
you're
can't.
doing good. You're doing good. So on the far left, we've got, maybe I'll do it like,
Okay, that's probably better.
okay. So how many fingers are to the left of your folded down finger?
4.
Nope.
No, 2.
Okay,
No.
look at the screen. Look at the
Okay.
screen, and then we'll do it on your fingers after, okay?
Okay.
Okay, now they are really good at folding down their fingers, okay? And they make it look easy. So they counted the 4th finger. So 1, 2, 3, 4. This is the 4th finger, and they folded it down. And you did that. You had that part correct. But then I said, count how many fingers are on the left. So we're going to ignore this one.
Okay, the left side of the 4, not the left hand.
Yes, yes.
Okay, so the answer is 3.
The answer is 3. So now where that bent finger is kind of breaks it up, how about the right side of the bent finger, but not the right hand? The right side of the bent finger. There are 6. So what's the answer?
36.
You're awesome. That's
Okay.
it. Okay. So let's do another one. I don't have another one with a picture, but I do want to practice it because it's great, especially when you don't have a calculator or whatever. It's much faster to do this once you're good with the trick. So let's try 9 times by 6. And like I said, I don't have a picture of this one, but 9 times by 6. So try that with your fingers.
Okay. Okay.
Okay, so now your folded down finger.
54.
You're awesome. That's it. Let's try 9 times by 9.
Uh-oh. I know the answer.
Well, don't do it from what you know. Fold down those fingers.
Okay, you said 9 times 9, right?
9 times 9.
Okay. $81.
You're awesome. That's it. Nice job. Okay.
Thanks.
And I will say the woman on the screen who has palms up, that's really hard for me. When I'm working on a tabletop, I'll go palms down. And that way, when I fold my finger, the table will help me. And it's a lot easier for me to read it that way. I should have said that originally. Okay. So let's move on. So let's go back to our multiplication table. How much do we already know, or do we have a good, reasonable strategy that would help us get the answer? So we can add our number. So everything in gray, we already either knew it or we had a strategy that would get us there. We added the 9s. Okay. So now the 10s, many of my students come to me and the 10s are really, really easy because they've already learned that all we have to do is add a 0. Whatever number we're multiplying by, we add a 0.
Or count by 10s.
Or you can count by 10s. But I will say I've had students in the secondary levels and middle school and high school, and I've had adult students using that counting by 10s. And it's going to be really challenging if you get to a number like, I have to see where I've got this. Okay, 278 times by 10.
Would that be 2,000? Would that be 2,780?
You're awesome. Yeah, you're a strong math student. I can't tell you how many students at Seeds, they will start writing that problem out, working it out the long way. Yep, that's it. All we have to do is add the 0.
Yeah.
So the next one, 10 times 59. What's 10 times 59?
Would it be 1,059?
Nope.
Nope.
I wrote it a different way this time. Here, I had another number times by 10. I flipped
it would be 5,000. It would be 5,910.
You are so close. If you were writing it down on a piece of paper, you would get it. So I know you probably have paper and pencil right there, don't you?
I don't.
Oh, you don't?
No. I don't know why. I'm so sorry.
Nope, it's all good. That just means you have to do it in your head. It's going to be harder.
590 because
exactly what it is.
Because it would still be 59 if you times it times the 1.
Yep.
And it's just a 2-digit. And it's just a 2-digit number, so it would go into 100. So the other one was a 3-digit number.
You are exactly correct. But you know what? Listening to you talk, I think that in your brain, you're multiplying times by 10, and you're kind of multiplying it out. And you're good enough and you're fast enough that works for you. There is a simpler way to just, if it's multiplied by 10, just add a 0. You don't have to worry about in your brain mentally, okay, times by 0, times by 1, just add the 0. So let me see I think I have another one up here.
Okay.
126. So if we were to just slam a 0 on there, what would that answer be? 126 times 10.
1,260.
Perfect.
Okay.
And I'm trying to remember if I have one more. Oh, I do. Okay, this one's really hard. 10 times by 39,518.
Okay. So it would be 395,018. And how would you say that? 1,800?
If you had it written down on a piece of paper, I can tell you, you would get it. You want to know what? Let me grab a marker and I'll write it down for you.
Okay.
It would be okay. So I wrote it down. There we go.
Oh, okay. So 395,180.
That's it. And so if you see it, because you're good with place value, I can tell, and you're excellent at reading these numbers. If you wrote it down, you would have it, no problem. Okay,
Great.
nice job.
Thanks.
Okay, so now filling in our multiplication table, keeping track of what our brain already knows. So we're going to add all of the tens. So it's not going to let me do that. Okay. It gets stuck on the transition sometimes. Try this one. There we go. So now all the tens, we can do the tens pretty quickly. So we're done with those. The 11s, a lot of my students, 11s are really easy for them too. And I'm guessing that you're one of those that's already figured out. The numbers 1 through 9, you just double it up. So 11 times 6, 66. 11 times 8, 88. So I'm assuming, did you already know that one?
Yes. There's probably 11s and 12s with multiplications. I can say probably up to 11 times 10 is where I'm strongest at. The 12s,
Awesome.
I would probably have to really practice to memorize them. Some I do, some I don't.
And we have some strategies for you. So it's all good. But I will say some of the 11s are really hard. One of them. It's really hard, and you just actually 2 of them. And it's just one of those, because at the end of this whole PowerPoint, there's a list of the ones that are still difficult and there aren't easy strategies for, and we'll talk about that when we get there. But you're right, the 11s and 12s, some of those are in there. But so anyway, so the 11s, at least 11 through 10 is really easy, because 11 through 9 here would be 99, and 11 times by 10, what would 11 times by 10 be?
It would be 110.
Nice, because we can use our tens trick on that one. But you can see I didn't color in 11 times 11 and 11 times 12 because I don't think those are easy. Those are some of the ones that you just have to memorize.
So. Yeah.
But that's okay, because we're, it's narrowing down so it's less overwhelming. Okay, so now looking at the 12s, a lot of people struggle when we get to the 12s. And so the hint, multiply by 11 and then add another. And this is, even I do it, because when my 12s, I didn't learn them when I was younger. I learned them after I became a math teacher. I went to memorize them. Back in the olden days, no one talked about memorizing your 12s. So once I became a teacher, so once I became a teacher, it's like, oh man, okay, I got to memorize those. So in my brain, what I do is I say, if it was multiplied by 11 instead, and then I could add more. So let me see what my first example is. Okay, so for instance, 12 times by 7. Well, I could do 11 times by 7. That problem was easy for me. 11 times by 7 would be 77. And then I'm a big believer in fingers. Okay, so I have to add on one more group of 7. So the first thing I do is I put out 7 fingers, because I get so many students when they're trying to count on, they lose track, and they don't know when they're finished, and they just keep counting. So I put out 7. So I'm at 77, and I've got 7 fingers now. So I'm trying to get it where it can be in the screen. I'm making it worse. There we go. Okay, so I'll count at the start. So I'm at 77, 78, 79, 80, 81, 82, 83, 84. And 84 is the answer.
Okay.
Okay, so let's try 12. Oh, it's not going to let me do it. Okay, let's try 12 times by 8. And so, Tylisha, we know 11 times by 8 is 88. Now add on 8 more for me.
88, 88, 89, 90, 91, 92, 93, 94, 95, 96.
That is it. Awesome.
Thanks.
And the next one, let's do, oh, whoops. What the, 12 times by 9. We know 11 times 9 is 99. Count on another 9. 99 plus 9 more.
Okay, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108.
That's it. Perfect. Okay, so 12 times by 10, we already know that one. What does 12 times by 10 equal?
120, because you just add the 0 behind
Awesome.
it.
So now we get to 12 times 11. And 12 times 11 is a hard problem, and we can't really use this other trick, because if I say, well, let's do 11 times 11 and then add another set, that's not going to work, because 11 times 11, that one's not easy either. That's on that list of the really hard problems. So here's what I do. I say, I know that 12 times by 10 is 120. So now I need, so instead of 10 groups of 12, I need 11 groups of 12. So I need to add on, I'm at 120. I need to add on another group of 12. Can you do that for me? We're at 120 and we're adding on 12 more.
Okay, 120, 121, 122, 23, 24, 125, 126, 127, 128, 129, 130, 131, 132.
That is it. I'm going to show you how I would count it, because you only have 10 fingers, and getting all the way up to 12 was tough. And you already said before, for the 10s, well, we could skip count by 10s, because I know you're good at skip counting by 10s. So let's do this. So we're at 120, because 12 times by 10 is 120. And I just need one more group. So I just need one more 12. So I'm at 120, and I need to add 10 plus 2 more. So what's 120 plus 10?
130.
Nice. Now 2 more.
132.
And the biggest fear, okay, it's faster to skip count the 10 and then add 2 more. Plus, you don't have to worry about messing up your counting, because anybody, when you're involved and you're busy and you're distracted, it's easy to be like 97, 99, 100. It's really easy to make a mistake. So that's just to make it faster, whatever. We could always skip count the 10. Okay, so let's see here. There we go, 132. You were correct. Okay. So now let's go back to our multiplication chart here. And we're adding, can't see everything that I've got. There we go. We just added, what did we do? We added all the 12s. Now we don't know all the 12s, but we have a strategy to get all the way through 12 times 11. But 12 times by 12, we don't really have a strategy for that one yet. Just like 11 times 11 didn't have a great strategy. Okay, so let's see, where are we at now? So now when we look at our multiplication chart, you can see we have a strategy, or we already have memorized almost all of the facts. And so when we started, it was like there were 144 problems to learn, but really it's nowhere near 144 that we actually need to learn. So get it to advance. Remember, in the beginning, we also talked about there are a bunch of duplicates. Almost half of our chart is duplicates, because like 4 times by 3 is the same problem as 3 times by 4. So really, all the ones with D's in them, those are duplicates. Those aren't new problems for us to learn. So that makes it even fewer of the hard problems that we have to work hard to memorize. So, whoops, that's not it. Okay, so we already know most of our facts. Here we go. Out of the original 144 facts, there are only 17 that need to be just flat out memorized. And we're going to talk about that in a minute. But before we do, there were a couple of other little tricks is the wrong word, a couple of other things that I wanted to talk about to kind of help you with the rest of those problems that are a little bit harder. Okay, the threes tables, they can be pretty challenging. There is that same trick that we used with nines, where we said when we add up the digits, they are always going to be divisible by 3. So if we have the correct, so like if we say 3 times 6, I think the answer is 18. Let me see, 1 plus 8, that's 9. Yeah, 9 divides by 3. That means that probably was the correct answer. But if I said 3 times by 8, I think that's going to be 30. No, I'm sorry, that wouldn't work. 3 times by 8, I think that's going to be 32. Well, 3 plus 2 is 5. That's not divisible by 3. Okay, so that's just, it's one of those, the threes you pretty much just have to memorize. Oh, here we go. 1 plus 2 equals 3. That's divisible by 3. 1 plus 8 equals 9. 2 plus 4 equals 6. There we go. Okay, so for the threes, you pretty much have to memorize them, but at least there's that pattern. The 2 digits add up to a number divisible by 3. Okay, but that piece of information we can use just when we're doing our fractions or our ratios or our proportions or our long division. And so let's practice that. So if I have the number 47,538, and I were to ask you, Taylisha, can we divide that evenly by 3? Does 3 go evenly into 47,538? Do you know how to figure that out?
Yes, it does. You add up 4 plus 7 is 11. And then 5 plus 3 is 8. And 8 plus 8 is 16. Plus 11 is 27.
You are so good at your mental math. You are so, I mean, that's a rare student that can work at that quickly. 27. Okay, so go ahead.
And then it gives you 27. And 27 divided by 3 is 9.
Nice. So it works. So the number, I can get it to show me. Sorry about that. So I can get it to advance. The number 47,538, I add up all the digits just like you did. It divides evenly by 3. So I know 47,538 divides by 3. Okay, so let's try. So yes, that one worked. Let's try 826. Does that divide evenly by 3?
No.
No, it does not. Because 8 plus 2 plus 6 is 16. That's a decimal answer. And so it's not going to be divisible by 3. Nice. Okay. So that's a trick. That's something you can use with the 3s, but a lot of the 3s are what I consider the hard problems, the hard to memorize problems. Now 4s are just tough. I mean, they just are really tough. And I found 2 strategies online and I wanted to share them. I'll be honest with you. Well, okay, the first strategy I think is the better of the 2. I don't, this one might help me. Some people are really good with doubles. And like when we did the multiplying by 2, you know, like 2 times by 8 is like 8 plus 8. Okay, so there's a strategy, it's called double double. So let's do this one, 4 times by 3. 3 plus 3 is 6, so now double that. 6 plus 6 is 12. 4 times by 8. 8 plus 8 is 16, so 16 plus 16 is 32. Some people are good with doubles. Let me throw you a problem. Let's do 4 times 12. Can you figure out what 4 times 12 would be?
48.
Nice. So this strategy would be like 12 plus 12 is 24, and then 24 plus 24 is 48. You also could have used our other strategy. Let me see, 4 times by 12. I know 4 times 11 is 44. So 45, 46, 47, 48. Cool. Like I said, it's a strategy that I've heard people talk about double double before, but you know, I don't know. I put it up there. I thought maybe some people could benefit. The other strategy, the more I thought about it, I'm not sure I even like this one at all, but I thought I'd go ahead and share it. It was interesting. It's one of those patterns like we talked about before. So I thought it's kind of cool because it's a pattern. Okay, their first step, they said, and hold up, I have to move this out of the way. They said, fill in the whole first row with zeros, and then fill in the second, oh, I'm sorry, before you even do this, you have to draw 12 bricks, and the 12 bricks represent, actually it's 13 bricks, represent the 4's facts. So this is like 0 times 4, 1 times 4, 2 times 4, all the way to 12 times by 4. Okay, so you draw the 13 bricks, 3 bricks, and then 2, and then 3, and 2, and 3. And it's really important that when you do the row of 2 in between, that you stagger them. So it looks just like this. Okay, so then they said, on the first row, fill in zeros. The second row, fill in 1s, and then 2s, 3s, and 4s. Okay, so you start by filling that out. And then you count the even numbers, or you count by 2s. So it's like 0, 2, 4, 6, and 8. And so you're writing the even numbers, but remember you have to go up and down because you have to go in consecutive bricks, whichever one comes next, going from left to right. And then you do that again. 0, 2, 4, 6, 8. And then the last row, you just have to remember you don't have any bricks down here. And you just have to remember you're just going to put 0, 4, and 8. Like I said, it's not my favorite strategy, but these are the answers. So 4 times 0 is 0. 4 times 4 is 16. 4 times 7 is 28. Rather than, I mean, I don't know that this is going to make the 4s really easy or really fast for anyone. But if you're learning your 4s, drawing it out on a piece of paper this way could be helpful because it's a way to encode that pattern into your brain. And when you're working visually and you're writing kinesthetically and you're saying it out loud, so it's auditorily, it just helps your brain to learn it more ways. But could be helpful for some people. Okay, so We already know most of our math facts. So out of the original 144, there's only 17 that would be the hard ones. Take out all the duplicates. So the hard problems are that these are the threes that are, I would consider hard to memorize. The fours, the sixes, the sevens, the eights, the 11s, and the 12. Okay, so these are the 17 problems that we so far, we don't have a quick strategy to kind of figure it out on the spot. So it'd be really helpful to memorize these. And to memorize them, I have a couple of suggestions, and I'll get to that in a minute. But before I do, Taylisha, do you want to try all these? Because I'm guessing you're going to do pretty well with these.
Yeah, I know these.
Oh, okay. I knew you would. Go ahead. Start with 3 times 3. Do all the 3, and I'll put up the answers.
Okay. 9, 12, 18, 21, and 24.
Yeah, your math teacher loved you. There we go. Let's do the 4s.
Okay. 16, 24, 28, and 32.
Nice. Do my 6s.
36, 42, 48.
Good. Try the 7s at the bottom of the screen here.
49, 56.
Good. How about the 8s?
64.
Nice. And 11 times 11. Do you know that one?
I believe it was 121.
You're awesome. You could have done 11 times 10 is 110 and then add on 11 more, but when you already know it, you already know it. And how about 12 times by 12? Do you know what that is?
Yeah, 144.
You're awesome. Good. If someone is watching this video and they are not as strong with their math facts as Taylisha is, one of the things I've recommended to all my students, I love the multiplication chart or the multiplication table like this. Make a blank one. I mean, you can do it on lined paper. Just get a ruler so you can make the columns going down. Always, I would recommend always practicing to 12 because those are the facts that really, honestly, you're going to be expected to know pretty quickly.
Yeah.
And so, so you can make lots of these blank charts, fill it in. You could even just go back and mark the ones that you're practicing with and verbally say your answers as you were writing it down. Just strategies. And once you've gotten pretty good and this is super easy to fill out the multiplication chart, that's a good time to start making flashcards. And I would recommend students make the 17 flashcards of the hardest problems and practice those after you've gotten pretty familiar. Yeah, because you don't want to start flashcards when they're super hard. When you don't know any of the 17, we don't want to do that first. And then also use an app on your phone. I was looking for different apps I could recommend, and there are so many of them, and everyone's got different phone brands and stuff. But that's another good way. If you just need to refresh yourself a little bit, you can get one of those apps for free and practice a little bit.
Yes.
So I think I have one more. Yeah. So these were the 17 hard problems again. I thought I'd leave them up there on the screen. Whoops. Let me undo that. Those are the 17 hard problems again. If someone was interested in what the hardest ones were, and then it's just work to learn those. But at least it's 17 and not 144. So anyway, I told you that this would be probably a lot easier than all those decimals you were dealing with. So hopefully I took it easy on your brain, and this was more of just a quick refresher for you.
Yeah, it was great. It really helped me refresh and kind of remember.
It's you just have to force yourself to think about it every once in a while.
Yeah.
Cool. Well, thank you. Let me turn this thing off.
Yeah. Cool.